Well, good morning. Today we're going to talk about stairs. I see so many people building houses on YouTube that just haven't got a clue about stairs. Um, I've built probably 50 sets of stairs lifetime. Of course, I'm 80 years old too. Um, I mostly do metal stairs, like stair channel and angle iron supports and a tread on it. But it's the same math as the house stairs. Actually, I think the house stairs are harder to build. Now, you see in here sort of looking a couple three treads and a bunch of dimensions all over everything. Now, those dimensions are going to be explained, but you only need 2 dimensions to build stairs. And then there's a couple of rules. I've written it down in text, and we'll probably go to that in a little bit here. But I'll just show you what we're looking at. There's building codes for stairs. In the U.S., we have 3 major codes. You have a residential code, an industrial code, and what I call the Coast Guard code, because that's my book came from the Coast Guard. Residential code, the stair treads all have to be 7.5 inches apart on rise. That limits you to the distance between your bottom floor and your top floor to equal multiples of 7.5 inches. That's not happening. If that was your goal as an architect to satisfy that stair restraint and dictate all your wall heights of the first floor or whatever floor you're on by that, well, I guess that would work. But if you go to the industrial regulations, they have basically 3 things. Run, that's how far the nose of one stair tread. Let me get my pointer here. We're going to call this the nose of the stair tread. From this tread to the next tread, that's this horizontal distance. In this example, it's 9.8750. That's run, R-U-N. We also have rise. That's from the part you put your foot on of one tread up to the height of the next one. In this example, it came out to be 7.6250. But that number is the critical number for building stairs. Everything comes from rise. I think this is about 14 treads, just to make a long staircase. In the Philippines, you have 10-foot ceilings, so you could actually have a staircase that has this many treads. In the U.S., you have 8-foot ceilings and floor joists for the next floor or something like that. It's going to be a little less. I numbered the treads here. I don't know why. Okay, so you have the run and the rise. If you multiply those together, those 2 numbers times each other, regulations say it has to fall between 64 and 82 inches, because we're doing inches today. Then you have another restraint that's run plus rise. You add them together, and that can equal only 17.5. That's not negotiable. The total rise is not negotiable, but the individual rises are. I think the maximum that they'll pass is 7 3/4 of an inch rise to rise. But it's not. Once you get past about 3 stair treads, it gets easier and easier. You got more to divide the error from your basically your guess, and it comes down to a really small number. And we're going to talk about 2 or 3 different ways that you can lay these stairs out. There's one other number. If you're doing any industrial stairs, you have what's called toe kick. Not necessarily on residential stairs. That's the space between the tread and the upright, and it goes across the end. It's called toe kick. It's the same thing as around your kitchen cabinets. When you're standing at your sink and there's a place for your feet to go up underneath of the cabinets, it's toe kick, and this is toe kick. Okay. So let's zoom this out a little bit. And actually, let's go to here. Oh, yeah, let's write all over ourselves. 106.750. If it was actually on the screen, that's what it would say. Okay, this is our total rise. And we're going to step back and look at that for a second. Okay, at the top up here, your foot is going to be on top of, in this case, we've drawn in carpet, a carpet pad, and 3/4 inch OSB. But the deal is that wherever your foot lands, that's where you're measuring your rise to. On the bottom down here, I did this as like an example of a stairs down to outside down to your sidewalk, or like if you had an apartment you were renting above your house or whatever. And this down here is ceramic tile on adhesive, tile adhesive on a concrete slab or sidewalk. Now you notice I'm drawing in this exterior because we're outside today, an uneven piece of ground here in the yard. That's to show you that when you're measuring this total rise, it's the vertical distance from where they end up, that's where they land at the top, to where they started from the bottom. This is not measuring from the edge of the floor down to a floor down below, because this can be off a half or 3/4 of an inch in the length of the set of stairs, especially if it's if you're putting the stairs in before the entire construction is done. I put the stairs in generally before I have a second floor. It's to get materials up and down and people up and down in some degree of safety. Okay, so we have this 160 point something or other. And what we're going to start off with is we're going to divide the total rise by 7.5, 7.5 inches. And that comes out to 14 treads. But there's a remainder. What you've basically done is taken your 160 inches point something, and you've subtracted all the 7.5 that you can out of it, and you have some inches that are left. It's in inches. It's not a percentage of rise or something. It's in inches, because you're starting off with inches, and you've taken away a bunch of them. What you have left is, on this case, 1.75 inches. And if you have 14 rises, you determined that when you divided the 7.5 into your total number, it comes out to 14 treads and 1.75 over that. So if you divide it by 14, you get 1/8 of an inch. And in this case, we're going to add it to the, because it's an overage. If you would have divided and come out to 15, you needed 15 for some reason. Who knows why? Then you're going to have to subtract it. But virtually every time you do this, you're going to add it. Only a special case do you subtract it. And you'd know that when you're doing it. It'd be obvious. Okay, so we're going to add 1/8 to the 7.5. We're going to get 7 5/8. That's for easy math. If you're using a cell phone, something like that, that's 7.625. It's 7 5/8, same thing. Okay, now down here at the bottom, and let's scoot this around a little bit. I know subscriber 7 is probably screaming at me right now because it looks like a class presentation. He doesn't like it. This is your 7.6250. The first tread rise, all the intermediate tread rises, and the last tread rise have to be exactly the same, or you don't pass code. And they can make you take it back down and start over. Not they rarely do, but you have to do some fancy talking. Okay, the height of this upright under the tread on the first one is 6.1250. You know that because you know how you have to have a number to put in this thing, the thickness of your tread. In this case, we're using framing lumber, 1.5 inches thick. So we basically have taken that inch and a half away, and what's left is this board here. It goes from what would have been the next tread down. Oh, for calculation purposes, and to stress the fact that the first, last, and all intermediates have to be the same height, we're going to refer to this as tread 1. That's the place your foot is when you start up them. We're going to call it a tread, though it's not actually a tread, but we're going to call it a tread. And this is 6 1/8. Now, if we go to the other end, this is the one that's jumbled up with carpet and everything. Well, it would be if I put it down where you could see it. Same deal up there. And this riser board on the top one is 7.3750. Now, it's a little disturbing to some people that there's 3 different sizes. All the rest of them in between are going to be the same. They're going to be 7.6250. And this difference in these numbers was derived because you had treads. There's the thickness of the treads. I've done this video once before and threw it away. It was so awful. I just couldn't stand it. Here's your, well, it's either the bottom or the top. I guess this is the bottom and this is the top. And this is the riser board for all the intermediate treads. So there's 3 different sizes of pieces that end up with the same thing. We're going to get on to why I cut these notches out here in a minute. Well, let's do it right now. Basically, you've got the width of the tread, and then you got your toe kick. You're not supposed to be putting weight on the toe kick. Of course, it's supported by the riser board nailed into the back of it, or screwed into it, or glued into it. But let's talk about this for a second. We're going to talk. Ooh, the numbers there. Okay. You notice this little line right here? That's a piece of the stair tread, or any kind of frame and lumber. Take a piece of 2x4. You can run through a table saw and make a nice, neat little piece. But remember, this is under your stairs. You got treads and risers. You can't see this from the front nor the sides. The stringers block your view on the sides, and the board blocks it from the front, and the tread blocks it from the top. This can be a square piece. It would be just as fine, easier to make. Doesn't have that, that pizzazz look to it, but it will work just the same. And that gives you a way you can put it's a glue block. You slap some construction adhesive on it and poke it in here. And then you'd put a little nail to hold it to the glue sets. Or you could put screws in. You can use Tight Bond 3 from Franklin. It's waterproof epoxy. Excellent glue. Doesn't cost all that much, especially if you buy it in a gallon. Now we have to decide something here. Do we want the stringer to be exactly even with the nose of the stair tread? In other words, this line here, if that was the piece of frame and lumber you use for your stringer, you want it to sit in like that. Now that's going to leave you a notch right here, because you're gonna when you cut in down here at the one below it, you're gonna saw back to, in my case, here, and then you're going to come down from the top here. Well, actually, anyway, there's 3 places that you can put the edge of your lumber. You can put it at the nose of the tread. You can put it at the base of the tread. That's kind of the preferred method, actually. Except in industrial stairs, where you make this even with the top of it. Easier to clean it, sweep it, because you can sweep stuff off to the side. And so, choice 1, choice 2, and choice 3. Now, some of this is going to be dictated by how wide of a piece of lumber you're using for your stringer. If we notched the treads, we would be cutting here, like this, and the distance from the notch you cut in to the back side of the lumber, if it was a 2x10, you'd have 5.2983. So 5¼ inches plus on a 2x10, and 6 and better 5/8 if it was a 2x12. Now, if you cut your notch clear back to the back and used a completely rectangular tread, you have 4.8499 here. And if you were using a 2x10, you'd have 3.46. So basically, you have less than 3.5 inches from your notch to the back side of the lumber. That's like saying you took a 2x4 and nailed some stuff on top of it to hang the stair treads on. You've made the weak point of your stair here about the size of a ladder, like a wooden ladder you climb up and down. It's not really stair treads anymore. The deal, I think, is to cut these riser boards to fit between the stringers. You anchor the bottom in right into the back of a tread, and the top of you is a glue block. Or if this was going to have ceramic tile or carpet on it, you could nail right down here into the end grain or the side grain, both of them through the side grain actually, or screws like decking screws. And the glue block is just a security. You can stick them up there or not. This doesn't have to be continuous. It's better to do it in like 3 pieces, 6 inches from each end and 1 in the middle. Depends how many stringers you put, But trying to get a piece of framing lumber that's straight these days is only going to touch a couple places. It's going to touch 2 places, and the rest of it's going to have gaps. You can clamp it, pull around with dog clamps or C-clamps or whatever, furniture clamps. But anyway, if you put this riser board between the stringers, then you go from 3.5 to 5.25, and that's not quite a 2x6, but it's a whole lot better than a 2x4. And if you had the 2x12, you'd have 4.84 at that notch, and if it was a 2x12, you'd have 6.6834. That's saying you notched the piece to here. That's your cut. Your cut line is down and over. Well, who made that okay. I made it into a group, so if I bump something, it doesn't it doesn't knock a piece out of place, and then you go to measure it later. See, this CAD, you put in a few numbers that and you basically use edit commands to get where you want to go. I'm going to move this. All right. So you could have put your framing square like that. We got to turn something off here. What am I doing? I didn't turn it off. Hit the wrong thing, I guess. Okay. So you can cut a notch to there. You can notch out the back of the tread, and you'll be setting your square like that. But what we're going to do is we're going to lay this out a little different. See this line that runs out across the back and up to the front? We're going to do it this way. Like the next tread up, there's a line there. This is just showing for construction. You can calculate the run and the rise. We already did that. We just divided by 7.5 and spread the remainder across all the treads, across the actual number of pieces of these that you have. And then it comes out right. The other number we have is the thickness of the tread. And if you have access to something other than arithmetic and a piece of paper, you can calculate the distance from this nose to that nose along the stringer. And so all these lines here will be that distance apart. And if you start at the right place at the bottom, which is the nose of the tread, or it's this cut here, right there, because this is the lines that are parallel at the rise height. If you go to where that one is on the first tread that you draw in, then you can step it off. This diagonal measurement times 1 times 2 times 3 out to times 13, and that'll give you this point for your square. These points along the front face of the stringer. Now you've got your framer square set. This, I've made it red for the rise and the run. The blue is part of the same framing square. You know, if you click it, it's the same framing square. But anyway, if you extend that line, like if you flip that square over, you could set it up down here and get that, or you could just put it beside it and continue the line. This gives you a starting point. You step it off by the same numbers you did in the front. I'm sure there's some place here where we have that. Okay, 12.4762. Now, you can measure across your framing square, across the 2 points, to get that number. You can use the Pythagorean theorem. You can use a drawing program, which since I got it turned on, I use that. But you've marked these distances on the back side of the legs. Okay, gives you a longer mark. Anyway, if you've got these things laid off front and back, what this line would be, obviously if you cut the whole line, you're going to cut the stringer in two. You're going to stop cut it someplace. But this, well, yeah. Okay, after you've drawn that line across from front to back, you put your framer square on the line, and you slide it left or right, and that gives you the point above it. Let you draw that vertical line, because when you stepped it off that times the 12 point something or other number, that's gave you where the how to get those lines that are one rise apart. So you got a horizontal line here. You can slide the framer square along that line until it matches up to the mark on the stringer in the front. Then you draw a vertical line down the short leg of the framer square, and that's the notch that you cut. So now we know how to figure the rise to make it all come out, which is the most important part of the thing. So when we figured it out, we know that this is the first spacer, and this is a riser board, and this is the next. But when we drew it out, it gave us this number here, because that's our diagonal here. Also, if you'd have set the framer square down here on the base, and it's got these 2 marks on it, that would give you that first number. I mean, you just draw the line and you can measure off from there. But after we got the number, we had to come back here, take away the height of the tread, and move that line down. It's the same angle, same frame of square line that would have drawn this or here. You're just gonna come down the thickness of the tread, because when you cut the notch, you're going to set the tread on top of it. It has to come back out to this off the screen place. How does that? Golly. Okay, so you've gone down to the thickness of the tread, and actually the total height is 7.6250. It's the same on this step as it is on the next one. The only difference is the riser board, because it can't go down the height of a stair tread because you've hit the floor or the sidewalk or whatever's down there. That's why it's shorter by a stair tread. Let's stop this video because it's getting long, and we're going to restart it here just pretty much immediately.